We stopped yesterday by talking about ways to solve for limits when you can't substitute in and get an answer. This one we did by factoring, and that's going to be some of the problems on the homework if you haven't gotten that far yet. The next kind of problem is a little bit different. We have the limit as x approaches 5 of the square root of x plus 4 minus 3 over x minus 5. The first thing you always want to try with a limit problem is substituting in. So let's try this. When you substitute 5 into the numerator, what do you get? Square root of 9 and 3 minus 3 is 0, don't you? So it's the square root of 9 minus 3, that's 0, over 5 minus 5, that's 0. So you don't have to necessarily show that every time, but I'm just doing it in the notes to show you, yep, we got a 0 over 0. And I told you yesterday 0 over 0 means, who remembers what I said? Keep going. Keep going. So there's got to be some math I can do to this. Now, because nothing is squared, I can't factor it. So the other thing that we're going to do is something you've probably never seen before, but it's not that hard. I need to recopy the problem. And I'm going to be multiplying by what is called the conjugate. I'm going to rationalize the numerator. And what this is doing is just taking an algebra problem and changing its close. We're going to change the way it looks. We're not going to change what its value is.
So we're going to undress the algebra?
No, we're not. We're going to just change its close. We're going to add some more close to it. We're going to multiply by some more close. So we're going to multiply the top and the bottom by the conjugate, which is the square root of x plus 4 plus 3. All you do is change the sign of the second term. The square root of x plus 4 plus 3. Now, why am I allowed to do that? Who said that? Say that one more time.
The second one, itself over itself would just be 1.
Exactly. I am multiplying this fraction by something over itself, and anything over itself is always equal to 1. And when you multiply something by 1, are you changing its value? No, you're just changing the way it looks. So that's what allows me to do this. So now when I do this, I need to put all these in parentheses. I need to FOIL this out. Now here's where the algebra comes into play. When you multiply these first terms together, what do you get?
That whole thing squared.
That whole thing squared, which is just x plus 4. Takes the square root off.
What?
The square root of something squared is, that's something. Okay? Now, because they are conjugates, the outside and the inside are always going to cancel. And then what is the last going to be? Negative 9. Okay? However, we're not going to multiply the denominator, and I'll show you why in just a minute. So what we're going to do down here is just write x minus 5 times the square root of x plus 4 plus 3, like so.
Spell.
Yes?
What is that on the denominator? That second parentheses right there. Is that the square root of x plus 4?
Yes. This parentheses and this parentheses match.
Okay.
I just put these two on the bottom side by side. Okay? Now, how does the numerator clean up? This is just x minus 5. Agreed? What good does that do?
You can cancel?
That's why we didn't multiply the bottom out, because I knew those were going to cancel out. So now I have the limit as x approaches 5. What is on top now? 1 over just the square root of x plus 4 plus 3. Now if I substitute in 5, am I going to get 0 over 0 again? Definitely not, because I've got a 1 on top. So now I'm going to substitute in the 5 and see what I get. So it'll be 1 over the square root of 5 plus 4 plus 3. So that's going to be 1 over the square root of 9 plus 3, which is 1 over 6, and there's the limit. eventually you're going to have to be able to determine what method to do. That one's pretty obvious, I hope, because it's quadratic and squared, you factor it. Whenever you have a radical involved, this is what you do. It's called the conjugate method. So in the homework, it's going to be called the conjugate method. Let me write that down. What we just did right here is the conjugate method. And this right here is the conjugate. Where you take the term with the radical in it and just change the second sign. Are you with me? Any questions? Okay. We have one more, actually a couple more problems to do, so I'll move on to the next page. I need to introduce you to a wonderful procedure. Some of you may already know what it is. I taught this in my regular pre-cal class last year. It's called the SMILE method for adding and subtracting fractions. I'm going to teach you how you can add and subtract fractions and never have to get common denominators ever again. How many of you have seen this before? A few of you have. Most of you are my former students. Okay. Now, before I tell you how to do it, let me talk about where the name came from. When I say the word emoticon, do you know what I'm talking about? Okay. When I teach this to teachers in the summertime as well, and I ask them what emoticons are, and about half of them don't know. But when I ask it to a class of students, they're all like, yeah, I know what an emoticon is. Okay. Emoticon, like smiley, or this one. Okay. Or this is my daughter's favorite one, right there.
What does that one do? What does that one even mean?
That's like your eyes are squinted shut and you're laughing. You're laughing so hard your eyes are shut. Okay. Now, the one that we're doing is actually a variation on that, which is like this, but I want you to turn it like a face. It goes like this, and like that. Okay? So you see that's like a smiling face with its eyes squinted shut. That's what it's supposed to be. This is the procedure that you do to the fraction in order to get the answer to the problem. So let me show you how this works. We're going to do number fractions for starters. We're going to do 1/2 plus 2/3. We're going to do it the old-fashioned way. What is the common denominator going to be? It's 6. Okay, so the common denominator is 6, which I need to multiply the first fraction by 3, second fraction by 2, and so I end up with 3 plus 4 over 6, which is 7 over 6. Do you agree with that answer? Okay. Now, the SMILE method with the same problem. I'm going to write a little bit bigger. 1/2 plus 2/3. No common denominators needed. Taking this picture right here, we're going to apply it to this problem. We're going to go this way first, multiply the 1 and the 3, and you get 3. Write it down. Whatever sign the problem is, adding or subtracting, is what goes next. Then we go the other way. 2 times 2 is 4. And then we SMILE, multiplying the denominators together. 2 times 3 is 6. And lo and behold, we get the same answer. Okay? Works every time. College math professors say, learn this. So I'm teaching it to you now. Some people say, why didn't I learn this 3 years ago? That would have been really nice, right? It would have been. But not every teacher knows how to do this. So it makes the calculus so much easier to do. Let's do another couple of examples. You try this one. I want you to do 5 over 8 minus 1 over 4. You have to start at the top left, especially when you're subtracting. You have to go this way first. Look up here and see if you got the same answer that I did. Are we good?
No.
No.
I got 7 over 8.
You added instead of subtracted.
Oh, I'm ready.
Okay. Let's take it one step farther. Let's throw some x's in there. 3 over 5 plus 2 over x minus 1. This makes rational functions so much easier. So we're going to go this way first. So we're going to get 3 parentheses x minus 1 plus 5 times 2 is 10 over 5 times x minus 1. And we never FOIL out the denominator. Never. So this will be 3x minus 3 plus 10 over 5 parentheses x minus 1. So you get 3x plus 7 over 5 parentheses x minus 1. Can you factor the numerator? You want everything as factored as possible. Does that numerator factor? No. So that's your answer. You're done. You have to distribute on top in order to collect like terms, but we don't ever distribute on the bottom. Okay? You see how this makes things a lot easier? You don't have to worry about common denominators? Okay. Now, this method is used to solve limit problems that can't be solved another way. So, we're going to take the limit, this is type number 3, the limit as x approaches 2 of 1 over x minus 1 minus 1 over x minus 2. You saw a problem like that the other day that you had to type into the calculator and solve. Now we're going to learn how to solve it by hand. Okay. First of all, we have a fraction within a fraction. So what I need to do is take the top of the fraction and make it into a single fraction. So the first thing I'm going to do is put this over 1, and I'm going to smile the top. So go through the process for smile and do the top of the fraction for me right now. When you're done, look up here and see if you end up with what I have. Very important that this x minus 1 is in a parentheses, because you're subtracting the whole thing. If it's not, go ahead and add those parentheses back on.
Ms. Bell,
Yes?
both the whole x gets negative, right?
The whole, okay, this one is the one that goes left to right here is positive, and then the other one is negative. Yes, the whole thing is negative. That's why it's in a parentheses. Okay? So now we're going to distribute the negative. We're going to have 1 minus x plus 1 over x minus 1 over x minus 2. Are we good so far? Okay. How does the numerator clean up the top of the numerator? What is that? Do the ones cancel or no? No, they don't. So it's going to be 2 minus x over x minus 1 over x minus 2. You agree with that? Okay, I'm going to do things a little different, just to kind of keep our fraction bar safe. That's the big fraction bar. Just kind
Where did
of
that 2 come from?
adding the ones. Adding those 2 ones right there. Okay, put that one over 1. What am I going to do next? Does anybody know? Flip it up. It's this divided by this. How do you divide fractions? You flip the second one and multiply. So we're going to flip this one up. We're going to have times 1 over x minus 2. And this one is basically gone. So we're going to come to the next line. We're going to have the limit as x approaches 2. 2 minus x times 1 is just 2 minus x over. These two, told you never to multiply them together. X minus 1, x minus 2. Leave them separate. Okay. Now, here's the big question. Can I cancel those 2 out? What do you think? No, you really officially can't the way they are. But what I can do, since this one is a positive 2 and a negative x, and this one's a positive x and a negative 2, they are the same except their signs are backwards. Does that make sense? So what I need to do is take this one and I need to factor out a negative 1. If I factor out a negative 1, that'll make the x turn negative, and I'm going to throw it in the back of the problem. And it'll, excuse me, I said that wrong. It's going to make the 2 turn negative. I'm going to throw it in the back of the problem. It's going to make the x turn positive. Do I need to say that again? Are y'all with me? Y'all are so quiet today.
So you only do that for the top one?
You could do it with either one. I just like x's first, so I took the one that had the negative x, and that's the one I took out, the negative 1. Now I can do this. Mark those out. So now I have the limit as x approaches 2 of negative 1 over x minus 1. Now can I substitute negative 2 in and get an answer? Yes, I can. So this would be negative 1 over 1, which is negative 1.
How did you get x plus? Oh, okay, you treat those.
Yeah. Okay. Now it's your turn. That's the hardest they go today. Right there. Now it's your turn to show. This is called, yeah, what do they call this one?
The smart method.
Well, actually, it doesn't say that because I teach the small method and I don't believe Mr. Giglio does. Okay. It's basically simplifying the fractions. Okay. I would like you now to try this one yourself. The limit as x approaches 6 of 1 over x minus 2 minus 1 over 4 over x minus 6. I forgot to do something on the last problem, and I'm going to do it real quickly. I'm going to move this up. If you substitute a 6 into the numerator, the first fraction will be 1 over 4 minus 1 over 4 is 0, right? The denominator will also be 0. So it is another 0 over 0. I didn't do that last time, and I should have. I just went straight into the problem. What is the first step going to be for this problem? What are we going to do first? Smile the top. Okay, go ahead and get started. Work with your table. I'm going to come around and check and see if you are getting the right answer.